Going to take a look at simple distillation and fractional distillation. Okay, so simple distillation is to obtain a liquid from a solid liquid mixture. Okay, from solid liquid mixture. Okay, then for fractional distillation, I'm trying to obtain a liquid from a liquid mixture. Okay, Okay, so now we're going to take a look at how does a simple distillation setup looks like. Okay, you are not expected to draw, but you need to know what are the different apparatus and what are their function. Okay, so the principle behind is that generally we have to use different boiling points. Okay, so distillation can be used to obtain the liquid from a solid liquid mixture. Okay, so if you take a look, right, okay, there are a few things that we need to take note. There's always a thermometer. Okay, make sure the thermometer you recognize where's the position. It should not be inside the liquid. It should be just at this position, okay, whereby you can just measure the temperature of the vapor that's leaving this round bottom flask and going into the condenser. Okay, the reason is because we need to measure the temperature of the vapor, okay, so as to identify the distillate. Okay, distillate is actually this thing that is collected. This is called the distillate. Okay, because the specific boiling point will help me to identify the liquid that I'm collecting. Okay, then next, okay, inside our round bottom flask, there's some porcelain chips, which is also known as your boiling chips. Okay, to ensure smooth boiling in this case. Okay, we also have a condenser over here. Okay, so the condenser, always remember that the water in should be nearer to the exit of the condenser so that to make sure that all the vapor, okay, can be cooled down from the gaseous to the liquid state. Okay, so many times students like to use the word condense, okay, but condense will not be able to explain the meaning. So cool down the vapor from the gaseous state to the liquid state. Okay, so from gaseous to liquid state. Good to write gaseous to liquid state. Okay, so the main essential things that we need to know is actually the condenser, the thermometer, and the boiling chips over here. Okay, and the reason to ensure to explain why the cold water direction is like this is because it is to help to ensure that the condenser is completely filled with cool running water and to ensure the part of the condenser near the collection is cool. Okay, so always remember that you want the exit, which is when the vapor is about to leave, to make sure that it has already cooled down and condensed to the liquid state. Okay, so this is your simple distillation setup. Okay, for the fractional distillation setup, it looks something like this. It's actually quite similar, but just that we have this additional thing called the fractionating column. Okay, for fractional distillation, okay, we are trying to separate a liquid mixture based on their different boiling points. Okay, so again, the bulb, which is the thermometer, is also placed at the fractionating column when it's about to leave so that I can identify the vapor based on the boiling point. Okay, you also need to memorize, okay, the purpose of the fractionating column. Okay, so the fractionating column consists of glass beads which help you to increase surface area for condensation of vapor. Okay, with the highest boiling point back into the round bottom flask. Okay, the reason is because there are usually two liquids. Okay, so the one that has a lower boiling point will be coming out first. Okay, so I want to make sure that the vapor of the higher boiling point remains and go condense back into, okay, the round condense back into the round bottom flask. Okay, other than that, okay, the various things like the boiling chips, condenser, okay, the reasons are still the same as your simple distillation. Okay, and just need to take note that it's always the liquid with the lower boiling point that will be distilled first. Okay, so now, okay, we're going to look at this graph, okay, to understand how what exactly happens, okay, when you actually start your fractional distillation. Okay, so you can see that in this graph, I'm trying to show a curve of temperature against time. Okay, so I have two liquids, ethanol and water. Okay, so ethanol has a boiling point of 78 degrees Celsius. Okay, water 100 degrees Celsius. Okay, you should know that ethanol will be distilled out first because of its lower boiling point. Okay, so in this case at number 2, you can see that it's a horizontal curve, horizontal line. It's because all the ethanol has been distilled. Okay, so the boiling point remains constant for a period of time. Finally, it will after it has collected finish everything all the ethanol, it will start to rise again so that you can collect the water which has a boiling point of 100 degrees Celsius. Okay, take note that boiling point usually the temperature will remain constant for a period of time.